This is the 8th problem in the grind 75. This one is called binary search. We're given 15 minutes for this problem, and so let's start the timer. So given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with O of log n complexity. Okay, well, I mean, the title sort of gives it away as to what we're supposed to do, but I mean, so does the complexity. So sorted in ascending, we have to find the target. Output is 4. So the index, right? Return its index, yeah. Otherwise return -1 because it's not found here. Let's see what our constraints are. 1. So it's at least length 1, the list. Let's see. The numbers can be really small or really big. Every integer is unique. Okay. Yeah, and it's sorted in ascending order. Okay, so let's see. So I mean, if I were to do this by hand, I would want to just have this as a binary search tree. But I also don't want to make my own tree node class right now, which, it could be done, but we're not given a whole lot of time. To do this as an array, so it's an array, one of these things, I think we're going to use 2 pointers. So let's see. So we can take, we'll split the list, or not really split the list, but let's think about this. So we'll have, this list is of length 6, right? 1, 2, 3, 4, 5, 6. Yeah. So length divided by 2 will yield 3. So I'm just gonna say nums dot length divided by 2. So let's see. So we'll yeah. This might be a recursive solution actually. Well, let's just again continue to think about what actually goes on. So our target is 9, right? So actually no, we don't need 2 pointers, so we just need to go to the middle of the list. So num divided by length will get us the middle of the list. In this case, we'll say it's index 3. 0, 1, 2, 3. And we'll check if the target is greater than the middle index. If it is, then we're going to take, so we're going to take the end minus the middle. Let's say nums dot length minus middle divided by 2 plus middle. And in the case that it's less than, we'll take the difference between middle and the start. Divided by 2. Okay, so if I can, I think we could just do middle minus start divided by 2. That makes a lot more, or well, let's see. I don't need to do, sorry. Because, for example, if the index is, in the case where we pick 5 and our target is greater than 5, num's length will currently be 6, middle will be in the index 3, and we'll subtract that and divide by 2 to get, yeah, so I guess we will have to actually add middle back. We'll get 1.5, which goes down to 1, and then we'll do plus middle to give us 4. And say our target was 12, then we would do, again, 6 minus 1 divided by 2, that would give us 0 plus 5. That would still put us at 5, though. Yeah, it's always these little details right here. I understand the overall concept, but I just don't want to make sure, I want to make sure that I don't mess up something small here. So let's say we're given an array of length 1. So let me just go to the drawing board. So say we're going to, and I don't actually, let's see. So we can give, say we have one target equal to 3. Say we have 1, 2, 3. Maybe target is actually the same for both. I'm just worried about handling the middle index properly. So let's see, if we go back to here and think about what we're going to do. When do we stop? When is our base case? So yeah, geez, we have to think about that. Okay. Let's say we actually have this example right here. Negative 1, negative 1, 0, 3, 5, 9, 12. Zero, 3, 5, 9, 12. And say in this case our target is 0. Okay. So again, we'll start at the middle index. So we'll just say we have a value called middle, and right now it's going to be equal to index 3, which is going to be 5. And then we see target is less than that, so we're going to want to do middle divided by 2, actually. Middle minus start divided by 2. Well, okay, let's just say middle minus start divided by 2. Or are we going to want to have upper and lower? I want to have, let's say, upper and lower. So currently equals index 6, lower currently equals index 0. So, sorry, 1 second. Okay. So mid equals 3. We're looking for 0. We know that 3 is greater than 0, so we're going to want to go down to this lower part. The middle index is 3, but the value is 5, actually, which is right here. And so we're going to take upper minus lower. Actually, no, we would take middle minus lower. Divide that by 2. So middle minus lower, that would be over 2. And this is for the case where the value, let's say target is greater than middle. But let's say the value was actually 12. Middle would be 3. We take upper, take the average of upper and middle, right? Why are we subtracting? Middle and lower. And then it would be, yeah, see, geez. I was just not middle plus upper divided by 2. And this is for the case where it's less than, using the same arguments as above. I'll try to separate that. Okay, so I think we know what to do now. Let me just write that down on our notes. In fact, that's where I should have done it in the first place. And sorry, I should have switched over to the notes. So let's see. Yeah, so this is just what I was writing out to understand what's going on. Basically, if our target is greater than our middle value, so say our target is 12 and our current middle value is 5, then we're going to want to take the average of the middle and the upper value. And these will be updated each time, upper or lower, either one of them. And then middle will be moved accordingly. So let me just switch back to the lead code screen, and we're going to say say target is greater than middle. That's the case. We're going to do middle plus lower divided by 2. Target is less than middle. We're going to say middle plus upper divided by 2. Okay, and we only have 2 minutes left, so that's cool. Let's see if we can pump out the solution in that time. Okay, so I'm not going to worry about a base case right now. I'm just going to worry about the implementation. So int upper is going to be equal to nums dot length, int lower is going to be initialized to 0. We're going to say, what are we going to say? I guess while upper does not equal lower, while upper does not equal lower, we're going to get the average. And actually, we're going to want to make this variable middle. Middle is equal to upper plus lower divided by 2. If it's the case that they equal each other, so for example, if nums at middle is equal to target, then we've succeeded, and we would like to return that index. In the case that else if, let's say, nums middle, nums middle is greater than, so we'll actually just to so the countdown is up, but I'm close to finishing, so I will do that. And just for the sake of consistency, equals nums middle. Okay. Else if target is greater than nums middle. Okay. Then we're going to say middle is equal to middle plus lower divided by 2. Else, so that should be the case where it's greater because it's not equal. So we can say middle is equal to some funky spacing. Maybe middle plus upper divided by 2. And we also have to update upper and lower accordingly. So if target is greater than nums middle, then middle equals and then upper equals middle and then lower equals middle. Okay, I believe this is correct. Let's run, and if it doesn't work, then we're actually going to have to stop here. Let's see. Oh, okay. There is a missing something here. Maybe that goes there. Is there an extra something? Okay, let's see. Missing return statement. Yes, okay. Sorry. So if we get through this whole thing and they come out equal and it's still not the case, then we're going to return -1. We should actually return, well, it's not a boolean. Okay, I'm actually going to stop here for the sake of time.